Good evening, statistics. I love AMI days so much. They're so productive and helpful and useful. I could not make better use of my time. Anywho, so sadly we don't have the time to just have a free day. We actually got to keep moving forward with the content. There's a ton of content and stats. It's not hard content, it's just a lot to keep up with, and we have to keep a good pace so that we can get everything we need to get covered while we have time. So let me answer a few questions from the Google form that I got. So hopefully that'll make a little bit more sense. And then we'll get moving on with the stuff. And then we'll have two questions throughout the video, and then your stat of the day. And I have a stat of the day too. So I'll talk about that once we get closer to it. But firstly, what is a standard deviation? Now, I want to compare these two formula. So you have the mean formula, which is the x bar is equal to add them all up and divide by however many there are. And that's an average. So that's how you typically find the average. And compare it with this formula. I know I flip-flop the x bar minus xi. I know Miss Goldie is what she calls herself, has it flip-flop, but it gets squared anyway. So it's not really going to make a difference with the sign. You add them all up and then divide by n minus 1. Well, if you think about it conceptually, a standard deviation is how the average distance people are from the mean. Because if you think about it, x bar is the mean, right? Xi is something that's not the mean. Where did the n minus 1 come from? Well, instead of however many there are, it's already included with the mean. So mean makes it n, but since we already have the mean up there, then it's n minus 1, so we go down 1. But if you think about it, the distance formula is a squared plus b squared equals c squared. Solve for c, take a square root. It's the exact same thing, actually. This is just the distance formula. If you really think about it, it's the average of the distances, which is really cool to think about. And we'll go a lot more in depth with that. And sorry, I just made that realization as I was talking about it. Wow, that's cool. But we'll go into it in unit 2 when we talk about this concept called a residual and linear regression and stuff. And it's going to make a lot more sense that way. But conceptually, you just need to think about it as the standardized, meaning average, deviation, meaning how far apart they are from the mean. So how far apart the average person is. And then UB and LB. UB stands for the upper bound or upper boundary or upper fence. It goes by 3 different names. LB stands for the lower bound. And those are your cutoffs for your outliers. And I know she goes well over the IQR plus or minus or times 1.5 plus your Q3 and minus your Q1 and blah, blah, blah. That's the one we're actually going to use. She also goes through a different one, which is like 2 times the standard deviations. Don't worry about that. No. In fact, actually, we're going to go a lot more in depth as to why that one won't be used as much versus this one with the box plots. But these are just your cutoff values for outliers. So if you have something that's above your upper bound, then that would be an outlier versus lower bounds, below your lower bound. And we'll do a lot more examples with that in person, but that's just the idea behind it. So that's how you calculate your outliers. And that's going to be the 2 main ones that we use. So the 2 standard deviations, we're actually going to talk about that today. And today's topic is going to be over normal distributions. So it's going to be the notes number 5. I know I haven't given those out in paper because I was expecting to be there and school on Tuesday. And yeah. But normal distributions are going to be something we work with for the rest of the semester, actually. And it's one of the most important concepts, which is why I want to go a little bit in depth with it. A normal distribution is if you have a perfect population, you got every single person in your sample, that's going to be considered a normal approximation. We're going to approximate if we don't have everybody. And there's going to be a few different caveats as to when we can use a normal distribution. But the normal distribution, she has a lot of different things about it, but it's symmetric. There's no skew on it. tried my best to draw a symmetric bell curve as I could. But that's if your mean equals your median, which is also equal to your mode, meaning it is perfectly symmetric. And right smack dab in the middle is going to be where your mean is. Now, we have this concept of an empirical rule. Now, the empirical rule is, also note that this symbol is a Greek letter. It's a lowercase Greek letter for M called mu. That's going to be your population average or your population mean. So if you have a sample, meaning you sampled out like 3 people, or you sampled out like 20 people, then this would be, you would use X bar. X bar means your sample mean. But if you got every single person in your population, means you wanted to think about all the American men, right? And then you went out and asked every single one of them. That would be when you use mu. That means you got your population mean. This, if you just took 30 American men, then you'd be using your sample mean. But if you got the population, you'd be using mu. Same thing with this symbol right here. It looks like a little circle of a hat on it. That's actually lowercase sigma. That's because that's your population standard deviation. For samples, we use the S of X, right? But here we use sigma. This is lowercase sigma. And also this is uppercase sigma. So Greek alphabet stuff, we use a lot of Greek stuff. And the reason why we use Greek is because sometimes you don't have enough letters in the American alphabet to not make it confusing. Plus, Gauss, which I talked about a little bit, Carl Friedrich Gauss, one of my favorite mathematicians, actually kind of did the math behind a normal distribution. And we actually use this calculus term called a Gaussian integral to find the area under the curve. And I'm getting off track. It's a cool concept. But the only important thing to come from this, or not the only important, it's one of the most important concepts, is that actually, if you have a normal distribution, that means that 68% of all of your sample will be between 1 standard deviation above your mean and 1 standard deviation below your mean, so plus and minus. So 68% of the population will fall more or less in between those two values. And we'll go through an example with that in a little bit. And then the empirical rule is what this is called. 2 standard deviations above your mean and 2 standard deviations below your mean, 95% of the population will fall in between those two values. If you go one step even further, where you have 3 standard deviations above and 3 standard deviations below, then that's going to be 99.7% will fall between those two values. What does that even mean? Well, let's go through an example right here. I actually did my own research on this because I totally wasn't self-conscious or anything about it at all. So we're going to talk about the average American male height, adult male height. I looked it up. So currently, right now, the average American male height, 69 inches, so 5'9". So don't at me. And then the standard deviation of those values are 3 inches. So we want to find out what two heights are between, or do 95% of all American males fall between. So, well, in order to do that, we take the average, and then we want to do the empirical rule. So that's going to be 2 standard deviations above and 2 standard deviations below. So let me find a good color for that. So that would be 69 plus 2 times 3. So that's 2 standard deviations. So 69 plus 6. So that's going to be 75 inches. So that's going to be your upper bound. And then I'm usually using interval notation because I'm just used to it at that point with pre-calcs up. And now we're going to do the same, but only this time we're going to do minus. So 69 minus 2 times 3, and 69 minus 6. So that's going to give you 63. Meaning that 95% of all American males will fall between 63 inches and 75 inches. So Think about that converted to feet and inches. So 6'3". And then 63 inches is going to be 5'3". Meaning that all American males, 95% of them, will fall between those two heights. So this is the height, average height. Now, Mr. Mazzola is 6'4", so do the math. So now let's do an even more interesting one. What percent are shorter than 6 foot? It's an interesting question, isn't it? Now, probably will tickle your fancy to convert this to inches, since our average and our standard deviation are in inches. So if you think about it, 6 foot is 72 inches. Don't know that? 12 inches in a foot, just multiply by 12. So this is 72 inches. And now if you think about it, that is only one standard deviation above your mean, meaning that it's going to be right here. Now, we probably have to draw a curve right here to kind of help us out here. So if you are right there, so 72 inches, that's one standard deviation above, and that means that half of your values are on this side. So right here, by definition, you're going to have 50%. So that's literally half. But in this little sliver right here, it's one standard deviation above. Doing the math, that's half of the 68% interval, meaning 34. So then this whole section is 34. So now that's going to be what type, or the percentile behind that. So add up the 50 plus 34. So that means that 84% of all American males are shorter than 6 foot. So that's not uncommon for a male to be shorter than 6 foot, okay? So just want to make that clear. Short kings exist. Now, here's a tougher question. What percent fall between 5'6" and 6'3"? It's a tougher question than it looks. So now, we're going to have to do a little bit of drawing out some stuff right here. So let's draw a little normal distribution. This is how you usually want to approach these. Now, going off of the numbers, we'll probably have to convert it to inches here. So this is going to be 66 inches, meaning one standard deviation below your mean. And then this is going to be, well, 6'3". That is actually right here, 75 inches. So here, this is 2 standard deviations above. So right here. And then that is 1 standard deviation below, right here. So now, going through the empirical rule, 2 standard deviations above would be 95% falling between these two values. But we really want to break it up into 2 different slices. This slice right here and this slice right here. So this slice right here is actually half of the 95% interval, because it's only this half, not the whole thing, meaning that it's going to be 95 divided by 2 is 47.5%. And then here, this is 1 standard deviation below, so that's actually going to be half of the 68% rule, meaning the 34. So add these two values together, 34 plus 47.5, that means that 81.5% of all American males will fall between 5'6" and 6'3". How about that? Isn't that interesting? Now, there's going to be a lot more examples to go with the z-scores, and z-scores are going to be the other half of 8 point, or the notes 5, and it's such an important thing that I want to spend time in person on it. But z-scores are actually a much more efficient way of going about it. So question 1 on your Google form is going to be, actually, I don't know. Let me think about that for a second. It's got to be something stat related, at least. Normal distributions. How's your day been? How have you been? Question one is, how are you? Yeah, that is question one is, how are you doing? But here's my stat of the day. And then question two is going to be kind of a follow-up to that. So let me do a screen share. I think I can share screen. So let me see. There we go. Look at that. Doing some tech. Oh, wow. Technology. She actually has a question in the notes about ACT and SAT scores. So I was curious about that. So I looked up the 2023 scores. Now, I don't know if you know, but I took the ACT. I did pretty decent on it. More specifically, I did pretty decent on the math section. Now, this is literally off of one of the ACT kind of websites. Currently, this is the composite. Is the mean is 20.8 and the standard deviation is 5.8. So my question two for you guys is, what scores will 95% of all people that take the ACT in 2023 fall between? What two values for composite? And more specifically, a follow-up question to that is, I want you to give me another one with the math scores only, meaning you're going to have to give me two intervals for question number two on your Google form. One is the 95% interval for the composites, and the other being the 95% interval between the math section. If you're curious, just do it on your own with the other sections too, if you're really, really curious about that. But they literally give you a normal distribution ACT bell curve, and they talk about it too, which is really cool. So, yeah, no, they literally give you that. Wow, that's actually, oh no! They did it for us. No, I don't like that. That just ruins my whole entire plan. But actually, this is a good way to check your scores. So do it on your own and see if you can actually find those values. Shoot. All right, hang on. I'm flabbergasted now. I haven't been this flabbergasted in a long time. Wow. Shoot. Well, that kind of put a wrench in my plans. Okay. Anywho, so those are check your answers down there. Or, I mean, if you find the website, by all means, great. But you could just scroll back on the video if you're curious about the answers. But and then you got your stat of the day. So yeah. Anywho, if you have any questions, email me. I might post the answer keys to 1.3 and 1.4. I know you haven't been at school to turn them in, but I'd rather you guys be able to check your answers. Now, I'll post the keys just to check your answers. If I find out that you copied the answers, you get a 0. But Missoula, how do you know if I copy? I know. Especially if they're just a lot of those questions are your own interpretation. So if you use the exact wording that she does, that's kind of blatant. It's there to check your answers. So if you already did them, which is good, you should have, use a pen to correct if you need to. If that's going to get me happy, and actually I'll probably earn you a sticker on your assignment if you correct it yourself. Saved me a lot of time, actually. So, and plus in college you need to do that anyway. In college you don't get grades on your homework. You're just expected to do it and not even turn it in. But if you have any questions, let me know. Stay warm, and I hope to see you soon.